Okay, so in this video we're going to be having a look at the AQA Higher Paper 2 for the topics on the Advanced Information List. Now, as you can see on the screen, there is a checklist here for all of the topics that are included that were released by the exam board. Now, throughout this video, all I'm going to do is I'm going to go over a large majority of these topics. I'm going to go over one type of question so that you can have something to base your revision off. Now, obviously, I am only going to be going over one type of question, so you do need to make sure that you do your own revision and you don't use this as your only source of revision, because obviously there's lots of different types of questions within each of these topics. But this should hopefully give you a nice overview and maybe give you some starting points to think about for your revision, and might just be a nice way to get some last bit of revision in, obviously before that exam. Now, if you want to get this revision list, then I'm going to show you how to get that, and as well there is a downloadable booklet that you can print off and you can practice all these questions either along with the video, or you can do it first or maybe even after the video, but I'll leave that completely up to you. So before we get started, let's just quickly have a look at that. So when you're on this video, this is from paper 1, but if you click onto the description, which you can see on the right hand side, there's two links there, one for the checklist and one for the booklet. So make sure that you go into those links, download the checklist, make sure that you download for AQA if you are doing the AQA paper, and then also go into the link for the booklet, again making sure that you go into the AQA folder and you can download the AQA booklets. While you're going through this video, if you do identify topics that you need to work on, if you scroll down to where all the bookmarks are, you can see that next to each topic, you've got the full lesson that you can have a work through. As well as that, if you click onto the video when it's paused, you can see down the bottom left it says there's a chapter. Sometimes that doesn't appear, so you might have to refresh the video, but that should always be there. So if you click onto that, it will bring up all the bookmarks of the video, and you can skip through, you can go back to specific points, you can find questions that you had a look at, maybe that you want to have another look at without watching all the way back through the video again. So that's all there and it's all set up for you. So again, don't forget to get all those downloads so that you've got everything that you need. Don't forget to like the video, don't forget to subscribe, leave me a comment and let me know if these videos are useful and helpful, but otherwise, let's get started. Okay, so when multiplying fractions, we first need to make them improper fractions if they're mixed numbers. So if we look at this fraction calculation that we have here, we've got 1 3/4. So 1 times 4, add the 3 would give us 7/4. And then for the other one, 1 times 3, and add the 1 would give us 4/3. Now we're multiplying these, which is nice and easy. We just need to multiply the top, which would give us 28, and multiply the bottom, which gives us 12. Now it says in this question to give your answer as a mixed number. So we're going to want to go about simplifying this and seeing how many times 12 goes into 28. So 12 fits into 28 twice, and there would be a remainder from 24 to 28, so there'd be a remainder of 4. So we'd have 4/12 left over. Now whenever we give fractional answers, we never give them like this without this fraction here being fully simplified, so you do need to check to see if that simplifies. This particular one, the numerator and denominator both divide by 4. So we'd divide those both by 4 and we'd get a final answer of 2 and 1/3. And that'd be our final answer there, given our answer as a mixed number and making sure that that little fraction there is fully simplified. Okay, slightly higher number, expressing 180 as a product of prime factors. When a number ends in a 0, just personal preference, I always like to divide that by 10, so I'd go for 18 and 10. But again, you could go for 2 and 90 and just try breaking it down that way. But I like to go for 18 and 10 because now both these numbers are relatively small. So neither of those are prime. Again, if it helps, just make sure you write down some of the prime numbers. There we go. So 18 is 2 times 9, 2 being prime, but I'm just going to keep going. 9 is 3 times 3. And then 10 is 2 times 5. Now if I'm happy that they're all prime, which I am, 2 and 2, they're definitely prime. 3 and 3, they're prime, and 5 is prime. So writing these out as a product of prime factors. Now if I read them from left to right, it's 2, 3, 3, 2, 5. Now it's personal preference for me, but I like to write them all in size order and group the numbers together. So 2 times 2 times the 2 3s times the 5. Okay, and now we can write it in index form. So we've got 2 2s, which is 2 squared. We've got the 2 3s, which is 3 squared, and we've got the 5 at the end. And there's our answer as a product of prime factors in index form. Now this question says find the value of the reciprocal of 1.6 and give your answer as a decimal. Now when it comes to doing reciprocals, it's much easier to write the number as a fraction. So straight away, let's write 1.6 as a fraction. Now to do that, we've got the 1, which is fine, just like a normal fraction, and then we've got a 0.6. So 0.6 is the same as 6/10, so it's 1 6/10. Now we probably want to simplify that just to make it all a bit easier. So if we simplify it first, we could write that as 1, and dividing both the numerator and denominator by 2 would give us 3/5. So we need to find the reciprocal of 1 3/5. Now to do that, we'll quickly make that an improper fraction. So 1 times the 5, add the 3, would give us 8/5, and then turning it into a reciprocal, or doing the reciprocal, is literally just flipping it over, so it becomes 5/8. Now this particular question has said to write your answer as a decimal. So if we just type that in our calculator, 5 divided by 8 comes out as 0.625. And there we go, there is the reciprocal of 1.6. It came out as 5/8, which as a decimal is just 5 divided by 8, which is 0.625. Now there's quite a good little trick for all of these little questions, so I'll explain it a little bit in this first one, but then we are just going to be applying a little bit of a trick for the rest of them, because they are quite nice and simple once you've got the hang of these. But having a look at this one, it says 32.7 has been rounded to 1 decimal place right down the error interval. So the error interval just means, essentially, if it has been rounded to 1 decimal place, what's the biggest and what's the smallest that number actually could have been? We refer to that, we use the language upper and lower bound. Okay, so we're going to have a look at what the upper and lower bound is. Essentially, what's the upper bound is the biggest number it could have been, and the lower bound is the lowest number it could have been as well. So thinking about the number 32.7, and I'm only going to do this for this one question, but if we think about a little number line, if I just imagine a number line, and here's 32.7 on my number line. Now the next 1 decimal place value above and below would be 32.8 and 32.6. Now thinking about this, if the number rounded to 32.7, then it could only be within these little sections here. It could be halfway between 32.6 and 32.7, or it could have been, and we'll talk about the upper bound, halfway between 32.7 and 32.8. Now those numbers in between 32.6 and 32.7 is 32.65, and in between 32.7 and 32.8 is 32.75. Okay, and it can sometimes help just adding a naught onto the end of these if it helps to sort of visualise that. So we can say in between 32.60 and 32.70 is 32.65. That can just help just to sort of visualise it a little bit better. Now in terms of the upper and lower bound, it could have been this number here, 32.65. Now 32.65, if we round that to 1 decimal place, does round to 32.7 or 32.70. But if you think about 32.75, this one here, it can't actually be that number, can it? Because that would round to 32.8. Think about our rules of rounding there. That 5 at the end would round it up to 32.8. Okay, but we're going to incorporate that into our error interval. So when we write our error interval, and it's going to be these two numbers here, okay, this one here is called our lower bound, and the upper one there is called our upper bound. Okay, but when we put this into our error interval, we're going to incorporate the fact that it couldn't actually be equal to that upper bound there. Now when we write our error interval, it looks a very specific way. We put something in the middle. We can either put 32.7 or we can just put a letter in the middle. I'm just going to put the letter X in the middle. We have 2 arrows pointing to the left for our inequality here. This is how we write it. And we put our lower bound on the left and our upper bound on the right. So our lower bound on the left, signifying our lower number, is 32.65. And our upper bound on the right is 32.75. Now we just spoke about the fact that it can be equal to 31.65. So on our inequality for that one, we put the equal to symbol underneath the inequality there. But it can't be equal to 32.75, so we don't have a little equal to symbol on that inequality. So that right there is our final answer. And that means, as an inequality, it means that our number for 32.7 has to be somewhere in between 32.65 and 32.75. But it can be equal to 32.65, but it cannot be equal to 32.75. It's got to be less than that, because as soon as it hits 75, it would round up. Now that's the logic behind why we write the inequality the way we do, why we write this error interval like that. But there is just a nice little trick. Now if you look at this original number, 32.7, to get the upper bound, the only thing that's changed is this extra 5 on the end. And that's going to always be the case for these ones. All you have to do is put a 5 on the end. And then if you look at the lower bound, again there's a 5 on the end, just here, but the 7 has dropped down to a 6. So when I'm doing these, and I'm going to do it on the next ones, I straight away find the upper bound, I just stick a 5 on the end, so 32.75, and then I also then do the lower bound, and I drop the 7 down by 1, or whatever number's at the end there, drop it down by 1, and again just stick a 5 on the end. So I'm going to do that on the next question, but there's a little bit of an explanation as to why we do it the way we do. But once you've got your head around this concept here of just sticking a 5 on the end and then dropping it down for the lower bound with a 5, you can actually do these pretty quick. You've just got to remember the way that the arrows point both to the left. You can always think about a little song there that might remind you to always put them to the left, and then the equal to symbol always goes on a lower bound there. Just thinking about the logic behind why it can be equal to that one, it can't be equal to the upper one. Okay, let's have a look at another question. Okay, so here's this one. 340 has been rounded to 2 significant figures right down the error interval. Now again, when it comes to these significant figure ones, 2 significant figures in this case could have been described in a different way again. So not in terms of decimal places this time, but if you look at the number 340, that has been rounded to the nearest 10. Okay, so it's been rounded to the nearest 10, and just thinking about it like that can actually help in this case. So I'm just going to write here nearest 10. That's the other way that we could have described 2 significant figures. Now again, there is a little trick here. We'll think about the logic behind it, but in terms of the nearest 10, well, if we think about a little number line again, I'm not going to do this for any others, but if we think about a little number line, 340, 350 would be the next nearest 10, and 330 would be the next nearest 10 below. And in between those, again for our lower bound and our upper bound, it'd be 335 in between 330 and 340, and it'd be 345 in between the upper bounds there, okay, the 340 and the 350. So in terms of actually getting these, I mean, that is our lower and upper bound there. We've got 335 and 345, but thinking about the little trick, if it's to the nearest 10, that means it could be 5 above and 5 below. And the little trick for this one is just the first 0 that you see, that is going to become our 5 this time. Rather than just sticking a 5 at the end, it's our 0. So if I put 340 in the middle, okay, and I'll just show you what I mean here. So in terms of the upper bound, which I always do first, the first 0 in this case is what becomes our 5. So it's 345. And then the same process as before, the number before that drops down, so the 4 drops down to a 3, so 330, and stick a 5 on the end, so 335. Okay, and you can see that from our number line, but I'm just thinking about how you can do these nice and quick without fully drawing out a number line. Okay, so it's been rounded to the nearest 10. When it's significant figures and there's no decimals involved, there's a slightly different trick here. So the first 0 turns into the 5 for the upper bound, and then same process again, drop the number before it down and add a 5 on. Okay, so a very similar question. It says R equals V over I, and again, you probably recognise some of these formulas from your physics or your papers, but let's have a look. V equals 43.52, correct to 2 decimal places, and I equals 5.437, correct to 3 decimal places, and this time work out the upper bound for R. Okay, and give your answer to 3 decimal places, and we'll deal with that at the end. Now, first things first, obviously, again, we've seen the words rounded to 2 decimal places, so we'll write down our error intervals. And again, you can put the number in the middle here, but I just tend to write the letter X, and I've just got into the habit of doing it. So for the upper bound, we get 43.52 and stick a 5 on the end. And then for the lower bound, we get 43.5, drop it down to a 1, and again, stick a 5 on the end. And then for our other number that's been rounded, let's write our error interval for that. So stick a 5 on the end for the upper bound, 5.4375. And for the lower one, 5.43, drop the 7 to a 6, and stick a 5 on the end. And there we go, there's our upper and lower bounds of v and I. Now this time it wants us to get the upper bound. So thinking about the logic from last time, in order to get the biggest possible answer, we want the biggest number on top. So we're going to want the upper bound of v on the top, the biggest number on top. And on the bottom, we want to divide by the smallest possible number. So the lower bound of I. And again, you can test out different numbers here. You can test out all the lower bound, the number itself, and the upper bound on the bottom. You can see you will get the biggest answer using these digits here. So feel free to try them all out. But you will see, obviously, this is the quickest way of getting your upper bound here. Because the other way of doing it is to test out all the different possible combinations until you get the biggest answer. But this is obviously just going to give you the biggest answer straight away. So having this little bit of knowledge is going to save you a lot of time. So let's find these numbers. The upper bound of v is 43.525. And the lower bound of I is this number here, 5.4365. So let's just plug those in. So 43.525 all divided by 5.4365. And let's type that into a calculator. So 43.525 all over 5.4365. And turn that into a decimal, you get 8.006070082. There we go, lots of decimals there. And we are going to then round this, as it says, to 3 decimal places. So the third decimal is the 6, so chop it after the 6. It's a 0 after the 6, so it's not going to change. It's just going to be 8.006. And there we go, there's our final answer to 3 decimal places. Okay, so a train takes 3 hours to complete a journey, correct to the nearest 5 minutes. The length of the journey is 260 miles, correct to the nearest 10 miles. By considering bounds, work out the average speed of the train. Give a reason for your answer. Now this isn't very nice, not a nice question at all, there's a lot going on here. Our first thing is that we have to work out speed. So our formula for speed equals distance divided by time. Okay, so we have to write down the formula for this one, so obviously it requires you to know that. Now we've got our fraction scenario going on, and we've got different elements going on in the question here. So we've got the distance, which is the length here, so we've got 260 miles. Let's highlight that, that's our distance. And we've also been given a time, so 3 hours, and that's to the nearest 5 minutes. So if we actually start to write these down, let's do the error interval of d, so for the distance. Right, so I'm going to put d there just to remind myself that's the one. So the distance there is 260 to the nearest 10. Now when it's to the nearest 10, remember that's the same as 2 significant figures in this time. So to the nearest 10 could be 5 miles above and 5 miles below. So our upper bound is 265 and our lower bound is 255. Again, do make sure you check out that video on error intervals if you're unsure on this one. But 255 and 265 are my bounds for the distance. Now I'm going to have a look at the error interval for the time. Now this is quite a nasty one here, okay, because it's given us the time in hours and it's given us the error interval in minutes, and it says the nearest 5 minutes. So in order to get this, let's turn 3 hours into minutes. So 3 hours into minutes is 3 times 60, 60 minutes in an hour, which is 180 minutes. So the time it takes is 180 minutes. Now it's to the nearest 5. Now remember, to get the upper and lower bound to the nearest 5, you add 2.5 on and take away 2.5 minutes for the lower one. So 180 add 2.5 becomes 182.5. And taking 2.5 away would become 177.5. Okay, so just be very careful when you're adding 2.5 and taking 2.5 away there. Now that's not going to be very nice, because we're typically going to want our answers in miles per hour. Now if we're going to do miles per hour, we need to turn this back into hours. So that's not particularly nasty, it's just that we have to remember to do this. So dividing them both by 60, we'll turn them back into miles per hour. And if we do that, 177.5 divided by 60, if I can type that in correctly, 177.5 divided by 60 doesn't give us the nicest of decimals, it gives us 2.958 and a recurring 3. But there we go, it's back into hours. And for the one at the end here, 182.5 divided by 60, again doesn't give us the nicest of decimals, it gives us 3.0417. 6 with a recurring 6, there we go. And that is our time back into hours. That'd be okay if we could give our answer in miles per minute, we could just leave it in minutes, but in order to do this we do need our answer back into hours there. So now we've got our error intervals done, we still need to actually go about using this formula. So we've got speed is distance over time. Now let's move that out of the way, let's put that up here. Okay, and we're going to have a look at working this out. So to get our upper bound, which we can work out first, to get our upper bound, let's have a look. What do we do for upper bound? We do the distance upper bound, so the upper bound of d, and divide it by the lower bound of t, the time, which is there, 2.9583. So let's just write that in. That was the upper bound divided by the lower bound. Thinking about speed is distance over time. So we've got 265, and we need to divide that by 2.958 recurring 3. I'm going to write down what that actually equals. Okay, so in order to get that decimal, what I'm going to do on my calculator, I'm going to type in 177.5 divided by 60 again, so that I have that decimal on my calculator screen. Okay, I'm just talking about this one just here, so I didn't have to type it back in. And now I'm going to type in 265 divided by answer, so that it does, so I don't have to try and type in that recurring decimal. There we go. And if I type that in, we get 89.57746. And then we've got a few more decimals, 4788. I'm going to leave it there because it tends not to go beyond these. Again, if I find that it does, I'm just going to have to retype this all back in again. Hopefully it doesn't though. Now to work out the lower bound. So for the lower bound, that is not an L. There we go. To work out the lower bound, we've got to do the lower bound. That is not, for some reason I keep wanting to write in upper bound. We have to do the lower bound and divide it by the upper bound. Okay, so picking those numbers out nice and carefully, we've got the lower bound of the distance, 255, divided by the upper bound of the speed of the time there. Right, and typing those in, what do we get? So the lower bound there is 255, divided by 3.0416. Right, and let's type that in. Right, let's get rid of this little miles per hour thing, I don't actually want that there. Right, so typing this into the calculator, and again what I'm going to do is I'm going to retype this calculation in here, 182.5 divided by 60, so I've got that decimal on my screen. So 182.5 divided by 60, so I've got 3.0146 recurring on my calculator, and now I can do 255 divided by answer. And I'm going to write that down, let's have a look, that gives me 83.83 561, and there's a recurring dot above the 8, but I can't write them all down. There we go. Okay, so let's have a look at this. Now this is a very bizarre one, because if you have a look already, you can already see that there's no amount of decimal places that are going around, because we've got 89.5 and we've got 83.8, so they are very far away from each other. So this is going to be a very, very bizarre question here. So if this scenario did arise, and you'd hope, and it is usually the case, that they are quite close together and they do round to a nice amount of decimals, but it could be absolutely anything. So for this particular question here, we are going to have to think about how we're going to round it. Now to even to one significant figure here, they don't round to the same amount. Well, that one on the top there rounds to 90, and on the bottom rounds to 80. So that's absolutely useless, so that's not going to work. So the only way that we could actually round this to the same is if we round it to the nearest 100. Okay, so the average speed, we're going to have to round to the nearest 100, which seems a bit odd because it's actually quite a distance away from that, but they both round to 100 to the nearest 100, and that is the most accurate that we could actually do this question. So I would have to say 100 miles per hour. There we go, and that would be to the nearest 100. There we go. Now, it's very rare that a question will do this, okay, because it just doesn't make for a very good question. But that's not to say that it can be ruled out, okay? It could actually happen. You could have a question like this where the only way it rounds is to the nearest 100 and it's quite a distance away. And if that does happen, then at least you know that you are able to do that. But to be honest, the majority of the questions do actually round to the nearest like decimal or significant figure or something like that. But that's not to say that it couldn't happen. So it's a good question, obviously, to bring up here. Obviously, if it does round to one of the decimals there, you've already done a few of those, so you know that you're absolutely fine to go about doing one of those questions. Okay, so when we have a negative indice, the negative in the indice just represents a reciprocal. And a reciprocal is just where you flip over a fraction. So obviously 3 at the moment is not a fraction, but it could be written as 3 over 1. So to do a reciprocal of that, which is what that negative in the power means, we're just going to write it as 1 over 3. Now that has dealt with the minus there, and if it was 3 to the power of minus 1, this would be our answer. It'd just be 1 over 3, but this is 3 to the power of minus 2. So a number in the power as well just means now we have to do the normal power, and a normal power of 2 is just to square the numbers. So I just need to square both these numbers, and that would be my final answer. So on the top there, we've got 1 times 1, which is 1, and on the bottom, you've got 3 times 3, which is 9. So our final answer is just 1 over 9. Now, of course, when you've got negative powers, you can also have fractions involved in the power. We're going to have a look at a fractions example as well. And of course, the piece at the start, so in this case, the number was 3, could also be a fraction, and in which case you just wouldn't have to write it as 3 over 1. You could just flip it over straight away. But let's have a look at one with a fraction involved. So this first one, we've got 25 to the power of negative a half. Now when it comes to these powers, we just need to remember what each piece does. So if we make some notes on this, the negative part of the power, as we've seen before, does the reciprocal. It flips it over. So it flips it over. The number on the bottom, underneath that line there, which I like to refer to as ground level, the number underneath does the root. So in the case of a 2, that would be a square root, and if it was a 3, it'd be a cube root, and so on. And the number on the top is just a normal power. So these are the 3 things that we have to look at when we have these combinations going on. And sometimes we might not have a number on the bottom, sometimes we might not have a negative, but if we have them all, we have to think about all 3 of these pieces. So it doesn't matter what order you do it in. Now, I tend to always go for this number on the bottom first, purely because it's easier to do the root of a number than it is to then do the normal power when the number's quite large. If we imagine there was a normal power of 2 on the top, it'd be a lot easier for us to square root this than it would be to do, say, 25 squared first. So I always do the number on the bottom first. That's just personal preference, although you can do it in any order that you like. So what I've got to do here, first of all, I'm going to deal with this number on the bottom. So I'm going to go for this root first. So if I do the square root of 25, we'll get the answer 5. So that's the root dealt with. Now I'm going to move on to the other piece. So I've got the flip going on, or the reciprocal. So if I flip 5 over, remembering 5 is 5 over 1, if we flip that over, it becomes 1 over 5. Now the normal power there is just a 1, and a normal power of 1, let's find a different colour, I've used quite a lot now. A normal power of 1 doesn't actually change anything. Anything to the power of 1 is just itself. So that 1 over 5 there would be my final answer. Okay, so looks a little bit trickier, but we're going to take exactly the same approach. First things first, we're going to have to get rid of this divide by 3. So times both sides by 3, and that's going to give us a single line equation to look at. So the top doesn't change, we're just reversing that divide by 3, so 4x plus 1 equals, and then we're timesing both of these by 3, so we get 6x minus 6. And then we're just going to treat this just like we did in the earlier questions. So get rid of the smallest value of x, which is the 4, so minus 4x. And that leaves us with 1 equals 2x minus 6. Then we can get the numbers on one side, so leave the 2x where it is, let's add 6 to both sides. And we get 7 equals 2x. And then we can finish that off just like normal. We can divide by 2, and that leaves us with x equals 7 over 2, which you can write as 3.5 or 3.5 if you want, but that's fine to leave your answer as a fraction there. It doesn't ask us to write it as a mixed number or anything. So there we go, 7 over 2 is our final answer. Now these are solved in a very similar way to solving equations, okay? But obviously it's not an equation, it's inequality. It's an inequality. It's got our inequality symbol rather than our equal to symbol. So we're going to have a look at actually finding a range of answers here rather than just one single solution. So when we've got a sort of an equation that says 3x minus 5 equals 7, we're finding the exact solution that actually gives us this value. Now this inequality in this question, this is going to run throughout the video, says 3x minus 5 is less than 7. So what we're actually doing is we're finding what values of x would obviously give us answers less than 7. And that's what we're actually finding here when we use this inequality symbol. But as I said, we're going to treat it in the same way as solving equations. Obviously, if you want to get yourselves clued up on solving equations, I'll try and link the video in the description for that, for solving linear equations when we've got an x on one side or on both sides. But we're going to do exactly the same process. So I'm going to assume that we have a good knowledge of solving equations before actually approaching this. So I'm not going to talk about all the ins and outs of how we solve equations, but I'm just going to show you that we're going to solve this in the same way. Now we'll come to actually drawing it on the number line in a sec. So before we get there, we need to actually solve this. So we've got a -5 on the left. Now obviously we want to isolate that x there. So I'm going to get rid of this -5 to start with. So if we add 5 to both sides, let's have a look what we get there. We get 3x, and that's going to be less than 7 add 5 is 12. So 3x has got to be less than 12. Now we can divide both sides by 3, obviously, because we want to know what 1x is less than, not what 3x is less than. So when we divide both sides by 3, we get x is less than 4. And that is our solution to this inequality here. X has got to be less than 4. Thinking about the logic behind this, look, if you actually put 4 into this equation up here, we would get 3 times 4, this inequality, sorry, I shouldn't say the word equation there. We get 3 times 4, which is 12, take away 5, and that would equal 7. Now, obviously, we want to know what's going to be less than 7, so what we found here is that as long as we put a number in less than 4, it's going to give us an answer there that's less than 7, and that's what we're looking for. Which values of x are going to be less than 7? So all we actually have to do now to represent this on a number line is we stick our circle above that number. So above the 4, just here, we'll stick a circle, and it's less than 4, so I'm just going to point it to the left. It doesn't really matter how far I go. I'm just going to point an arrow saying it's got to be all these numbers here less than 4. Now obviously this circle here, that I've drawn above the 4, let's do this in a different colour. This circle here can be open, and what I mean by open, just like I've drawn it there, it's empty in the middle, or it can be coloured in the middle. Now there's a little way of remembering how whether it's coloured in or not. The other inequality symbol is we could have had this little equal to symbol on it as well. Now that little equal to symbol there has, and this is the way I like to remember it, it's got a little bit more ink on it in terms of when we draw it there's more ink. Now if there's more ink on the inequality symbol, there's more ink in the circle. So if it did have that little line underneath it, we would have a coloured in circle instead. There we go. But as this doesn't have the extra ink on the inequality, we're not going to put the extra ink there within the actual circle above the number. So we're going to leave it as an open circle, but I'm going to use that logic throughout these questions here. When we've got the extra ink on the inequality, we put the extra ink on the circle. That's just a nice little way of remembering it for you. It says solve the inequality and show it on the number line. So within this inequality here, look, we've got 2x plus 3. Now if I imagine that one of these sides wasn't there, let's just imagine this isn't here for the minute. If we just had that question, look, it's very similar to the one that we had in the first instance. Okay, we just subtract 3 and then divide by 2. Likewise, if we just imagine that the other side isn't there, I know it's written on the other side, it's what we had before, but again, we just subtract 3 and divide by 2 and we get our solution. Now we're not actually going to do anything different, but in this case, look, when we subtract this 3, to actually start isolating this x, all we're going to do is we're going to take away 3 from both sides. So I'm actually just going to take that away from both sides. I'm going to write -3 and -3. And when we do that, look, -5 take away 3 is -8. And that is the equal to symbol under that. Then we'd just be left with 2x in the middle. And 7 take away 3 there is 4. And there we go. Obviously I want to have x on its own. So now I want to divide by 2, just like we've done before. That'll give me the x in the middle. There we go. Keep all the symbols the same. Dividing them both by 2, 4 becomes 2, and -8 becomes -4. There we go, and now it's an inequality that we can draw on the number line. Now we've just got that x isolated in the middle. So it's a very similar process to what we did in those early questions. It's just that when we take away the 3 or potentially add the number if it was a negative in the middle there, we just do it to both sides. And then when we divide as well, just obviously dividing both sides. So very, very similar to what we were doing before. You just have to do it to the left and the right this time rather than just the one side. So again, putting the numbers on these. So -4 we've got a circle on, and +2 we've got a circle on. We're definitely going to join them together. I've just got to figure out if any of these are coloured in. So the one on the left there had the equal to symbol right next to that -4. So I'm going to colour that one in just to show that it can actually be equal to -4. Right, there we go. And that is our inequality there, drawn on the number line with a bit of solving in the middle. So I've got a couple of these for you to have a go at, both of them where you're solving in the middle. Again, you could always just think about the integer values that fall into this as well, just as an extra little step. So let's just write down the integer values. So we can have -4, it can be equal to that. We can have -3, -2, -1, 0, 1, and we can't have 2, so if you did write it, you'd have to cross that one out because we can't have the 2. There we go, so we can just get rid of that 2 at the end, and they are the integer values that fall between that inequality there, the whole number values. Obviously we can have decimals in between 1 and 2, we could have 1.5, 1.7, you know, any old decimal that you can think of going in there, but we can't actually have 2 itself, so we won't include that in terms of an integer value. Okay, so the point 34 lies on the circumference of a circle, centre 0, 0. Work out the equation of the circle. Now it's quite a nice actual easy way of doing this, because if we know that this point is definitely on the circumference, then we can just use our equation of a circle. And there's 2 different ways I'm going to look at this, but I'm going to start off with this one, because this one's quite a nice one. Now we know the equation of the circle is x squared plus y squared equals the radius squared. So if we just plug these numbers in, 3 squared being the x coordinate, y being the 4, so 4 squared, and that's going to again equal the radius squared. So if we work this out, we'll get 9 plus 16, which equals 25. Again, that equals the radius squared. So if that equals 25, then we can write our equation there. So we have x squared plus y squared equals 25. There we go. And although it doesn't ask for it, again, we could think about what the radius is here. If we did the square root of 25, we would get 5 as our radius. Okay, so obviously that's not part of the question here. It says work out the equation of the circle, but just thinking about that as well, you could actually get the radius there as 5. Now, if the centre wasn't at 0, it'd be a little bit trickier to do because we couldn't just sub it straight in. So we'll have a look at another way that you could look at this, because we're going to have a look at one where the equation of the circle, there we go, is not at centre 0, 0. But if we think about this as a little diagram, I'm going to do a little sketch of this. So if we had our circle, we've got centre 0, 0, 3, 4, let's just say it's up here. If we wanted to find the length of the radius, which obviously would help us to find the equation of the circle, we could actually draw this in. This is quite a good skill to be able to have here, to be able to do this for the progression of this topic. But if we actually draw a line going from 0, 0 to 3, 4, and think about the kind of shape we could make here. So we can make a little right angled triangle. And thinking about what this little right angled triangle looks like, going from 0, 0 to 3, 4, well, if it goes from 0 to 3 on the x coordinate, that is a run here, or a change in x of 3, and going from 0 to 4, that is a rise or a change in y of 4. So actually we could use Pythagoras to work out the length of the radius here. So I could just do a bit of Pythagoras, so square them both, add them together and square root them. So 3 squared plus 4 squared, and then square root our answer, which is the square root of 25, and the square root of 25 is 5. So there we go, that's another way of showing that the radius is 5. And then once you've got that, you can obviously put it into your circle equation. X squared plus y squared equals 5 squared, and again squaring that 5 to get you 25 to get your equation of the circle there. Okay, so a slightly harder question here, and you'll see why when we work this one out. So we've got y equals mx plus c, and we're going to work out the equation of the line between these 2 points. So the change in y over the change in x, let's see what we get. So from 4 to 8 is positive 4, and from negative 3 to 5 is a movement of positive 8, so it's 4 over 8. Now I've got a fraction here, we can simplify that. So divide the top and bottom by 4, and we get 1/2, okay, or 0.5. Now it doesn't matter whether you use fractions or decimals here, it's completely up to you which one you prefer to use. I think I'm going to use it as a decimal, I'm going to keep it as 0.5, and let's put that into our line equation. So y equals 0.5 x plus c. Right, let's pick a coordinate. I'm going to go for this one here just because it's got 2 positive numbers in, but it's completely up to you, it doesn't actually matter which one you use. So let's sub that in. So we have 8 for y, so 8 equals, we've got 0.5, lots of the x coordinate there, which is 5, plus c. There we go. So 0.5 times 5, or half times 5. Let's have a look and see what that is. So we get 8 equals 0.5 times 5 is 2.5. Remember, if you times by a half, it just halves the number. So 2.5 plus c. And then we need to subtract 2.5 from both sides to figure out what c is there. I mean, you can just use logic. From 2.5 up to 3 is an extra half. And then it's an extra 5 to get to 8, so it's 5.5. But if we subtract 2.5 from 8, we get 5.5 equals c. And then we can plug that in place of c up in our line equation there. Okay, so let's write that out. We get y equals 0.5x plus this 5.5. There we go. And there is our line equation. So y equals 0.5x plus 5.5, which again you could write as a fraction if you want. So whatever value you get for the gradient, obviously just treat it as a fraction or a decimal, and just obviously careful on this step right here. Just when you multiply those to get this value of 2.5, whatever that decimal multiplication is, just be very careful with that. So a line passes through the points 1, 5 and 5, 7. Find the equation of a perpendicular line that passes through the point negative 1, 7. Now this doesn't give us a line equation, which means we don't have a gradient, which means we're going to have to work one out. So we have been given this information that a line passes through these 2 points. Obviously, if you remember from the last video, we can have a look at the change in y over the change in x to get the gradient. So we don't even need the line equation. Because we've got these 2 points, we can find it ourselves. So going from one point to the other, the change in y, which we're going to do over the change in x, but the change in y goes from 5 to 7, which is a change of positive 2. And the change in x goes from 1 to 5, which is positive 4 or 2 quarters. So if we simplify that down, we get a half. So our gradient at the moment is 1/2. So if I want the perpendicular gradient, which we do for this because we're looking for a perpendicular line, we'll do the negative reciprocal. So negative 2 over 1, which is negative 2. Right, there we go. And now we can put that into our line equation. So y equals negative 2x plus c. And then again, just like before, we can sub in our coordinate. So 7 is the y coordinate, which equals negative 2 times x, which is negative 1, plus c. Negative 2 times negative 1 is positive 2. Those negatives cancel each other out, so 7 equals 2 plus c. Solving that, take away 2 from both sides to get c on its own. We get 5 equals c, or c equals 5, and we can put that back in place of c up here. So y equals negative 2x plus the 5 there. There we go, plus 5. And there's the equation of our line. Okay, so for this question, it's all the same process, but you're just going to have to find the gradient first. Okay, so find the equation of the tangent to the circle with equation x squared plus y squared equals 17 at the point 1p, where p is positive. Hence find the coordinates where the tangent intersects the x-axis. So there's 2 extra steps here. We've not got the coordinate where it intersects, and it's also asking us to find where it intersects the x-axis. So we're going to take this in steps, but let's have a think about what this would look like to start with. So we know it's a circle. We know it's centre 0, so we can draw a little sketch, even if it's not very good. There we go. And we can think about where this coordinate is. So 1p, where p is positive, is going to be over here in the positive quadrant there. So let's have a look. Let's draw that in. Okay, and let's just draw a little sketch of this. So that coordinate is 1p. I'm not going to write the p in for the moment because we're actually going to figure that out. And then we know it's centre 0, 0. Obviously, we're still going to be looking at finding out the gradient of the radius here. But we've got the tangent going down, it's intersecting the x-axis over here. So this here is where it intersects the x-axis. So this is what we're looking for here, this coordinate. And that's what we're going to find in a sec. So let's have a think about this. Now we can't find the gradient of the radius unless we know that coordinate there. So we can use this equation of the circle to find that coordinate. As we looked at with equations of circles, if this is definitely on the circumference of the circle, then it has to balance within that equation. So if we sub this coordinate into the equation, let's see what we get. 1 squared is 1 plus y squared, which we don't know. We could call it p squared if we want. And that equals 17. And if we solve that, so take away 1 from both sides, the 1 squared, we get y squared equals 16. And then the square root of that to get y is going to equal either 4 or negative 4. Now it says that p is positive, so it's got to be the positive 4 there. Again, if it didn't tell us that p was positive, we'd have to have a diagram to know whether it was there, otherwise it could be either. But in this case, it does say p is positive, so p is 4. So there we go, we've got our coordinate for y there, 4. Now we've got that, now we can find the gradient of the radius. Okay, so we can draw in our little right angled triangle again, we can find the gradient and we can follow all those other steps. We will have a look at this last step though at the end, the coordinates where the tangent intersects the x-axis. That's going to be our final step, but first, if we find the equation of that tangent, we'll be able to use that to find that intersection point with the x-axis there. So following our normal steps, let's find the gradient. So the gradient is from 0 to 1, 4, so that's going to be 4 as our change in y over 1, which is just 4, and our perpendicular gradient, negative reciprocal, minus a quarter. There we go, now we can plug that into our line equation. So y equals minus a quarter x plus c, and let's sub in this coordinate. So we've got 1, 4 to sub in, so 4 equals minus a quarter times 1 is minus a quarter, so that's quite a nice one, minus a quarter, plus c, and then adding a quarter to both sides, we get 4 equals, sorry, I've not actually added the quarter over, add the quarter over, we get 4 1/4 equals c, and then from there we can write our line equation, plugging that value into c up there. So we get our line equation as y equals minus a quarter x plus 4 1/4. There we go. And obviously up until this extra step, that's what we've been doing on the previous questions there, with the extra step of actually finding the coordinate. Well, that wasn't too tricky in this step here, just to get y equals 4. So now it says, find the coordinates where the tangent intersects the x-axis. Now this is something that always tends to throw people, but right here, this coordinate, we actually already know one of the coordinates there. We don't know the x-coordinate, obviously, but we do know the y-coordinate, okay? The y-coordinate has to be 0, okay? Because it's on the x-axis. If you think about the y-axis over here, this is 0, we already know 0, 0 there is on the x-axis, so the y-coordinate has to be 0. And because we know that we can sub 0 in place of y here in our equation. And if we do that, so we know y is 0, we can have 0 equals minus a quarter x plus 4 1/4. There we go. And that we can only do that because we know the y coordinate at that point. Now we just have the one unknown in our equation, we just have this value of x, so we can try and solve this for x. So if we subtract for this 4 1/4 from both sides, we get minus 4 1/4 equals minus a quarter x. And then we can divide both sides by negative a quarter. So we've got 4 1/4 divided by negative a quarter. They're both negative, so our answer is going to become positive, which we know it's going to have to be positive as it's over in the positive quadrant there. And if we divide by negative a quarter, well, a quarter fits into 1 4 times, so it must fit into 4 16 times, plus the extra quarter there gives us 17. So if we solve that, we get x equals 17. Okay, that's just me doing negative 4 1/4 divided by negative a quarter. Again, if you've got a calculator, that's nice and easy, but just remember a quarter fits into 1 4 times, so it has to fit into 4 16 times plus the extra 1 there, which is 17. So the coordinate there is 17 0, and that'd be our final answer there, 17 0. There we go. Lots going on that question there. And again, don't forget, you could always use your fraction rules. If you didn't have a calculator, it wasn't a nice easy one, you could do, let's have a think how we would write that. The negative 4 1/4, we could make that top heavy. So 4 times 4, 4 big times the bottom is 16, plus the 1 is 17, so it's negative 17 over 4 divided by negative a quarter. And you could just apply normal fraction rules to that, so keep the first one, flip the second one over, and then simplify it. So you do 17 over 4 multiplied by 4 over 1, and then obviously just simplify it from there. So there are other steps you could take if it was particularly nasty. Okay, so this one here, we've got it a little bit jumbled up, it's a little bit different to the last few, but let's just follow the exact same process and see what we get. So first bracket, 4 times the x gives us 4x, and 4 times the negative 3 gives us negative 12. Now moving on to the next bracket, but again, just being careful because we've got a negative 2 at the start. So this time it's negative 2 times the number first this time. So negative 2 times 1 is totally negative 2, so take away 2. And then we've got negative 2 multiplied by negative x. So the negatives are going to become positives because we've got a negative multiplied by another negative. So we've definitely got positive. And that's 2 times the x, so plus 2x. Negative 2 times negative x is positive 2x. And again, just tidying this up just like before, so 4x and the other x is at the end this time, so 4x plus 2x is 6x, and negative 12, take away 2, is negative 14, so 6x minus 14. Again, just be very, very careful with whether the number is negative or not. Obviously this was a negative 2, particularly careful when you times it by this negative x there to make sure you get your symbols right. Here we go, so expand and simplify this one, so we have 2x minus 1 and 2x minus 5. So let's see what we get here. So 2x times 2x is 4x squared, and 2x times negative 5 is negative 10x. On to the underneath, negative 1 times 2x is negative 2x, and negative 1 times negative 5 gives us positive 5, 1 times 5. And then again, just finishing it up, tidying up what's in the middle here. Both are negative, so just be careful. We've got 4x squared, negative 10 take away 2 is negative 12, so negative 12x, and then plus 5 at the end. And that's how you expand them when we've got coefficients greater than 1 in the bracket. We've got negative 2x in the middle and negative 15 at the end. So let's draw our brackets and think about what numbers times to make 15. So we've got 1 and 15, or 3 and 5. Now we've got negative in both of these, so the only options I can have to get a negative 15 at the end, I've got to have one that's positive and one that's negative. Okay, otherwise we're not going to get a negative answer at the end. So let's have a think about that while we're doing it. So 1 and 15, there's no way I'm going to make negative 2 out of those two numbers. 15 is too large, pairing it with the 1 there, so it's not 1 and 15. But I can make negative 2 out of 3 and 5. Just got to be very, very careful here the way that I get it round, because I can either have negative 3 and positive 5, or I can have positive 3 and negative 5. So just got to think, in order to get negative 2, the pairing that I want to do is I want to have 3 take away 5. So I want to have plus 3 take away 5, and that would allow me to get negative 2. So I just need to stick those numbers in, plus 3 minus 5. And when you've got this option with the positive and the negative, do make sure that you double check. Just thinking to yourself in your head, plus 3 take away 5, does that definitely make negative 2? Yes, it does. So we're happy with that one. We've got a 2x squared. So again, I'll link in the description the video for obviously factorising harder quadratics. I will explain them a little bit, but I won't go into as much depth as I did in that video. So do check that one out if you're not sure on how to factorise these. Now in terms of a 2x squared, that means in one of our brackets here, we're going to have a 2x when we're factorising it. So if I set the brackets up, we've got a 2x and an x, it's all equal to 0, and we just need to figure out where the numbers go. Now if we've got a 1 at the end, our only factors can be 1 and 1, but one of them is going to be doubled. Okay, obviously when we expand our double bracket here, we've got a 2x and it's going to double that 1 in the other bracket. So as they're both 1s, we know they're both going to be 1s here. We just need to figure out the symbols. Now we want minus 1x, or minus 1 in the middle. So in order to make minus 1, we're going to want positive 1 take away 2. So as this one over here is going to be doubled, we'll make that one become our minus 2, and this will be our positive 1 here. And obviously you can go about expanding that just to check that it matches, but there we go, that is going to match. We're going to get plus 1 on this expansion here, plus 1x, and we're going to get minus 2x when we expand that one there, and that'll give us minus 1 in total. So in terms of obviously getting our solutions here, it's very similar to what we just looked at. If we just set them both equal to 0, this one here is just going to become x equals 1. Obviously we haven't got a coefficient there, and this one here, we're going to flip the sign, so x is going to equal minus 1, but then we're going to divide it by the 2. So minus 1 over 2, or minus a half. And there's our two solutions, x is minus a half, and x equals 1. And again, you could obviously draw your sketch for your quadratic there. Just thinking about what it looks like, it's going to go through 1 and minus a half. And you could draw that in, there we go, 1 and minus a half, and that's where our two solutions are. So let's have a look, and let's just write down the values of a, b and c. I always write these down. So a equals 3, b equals 2, and c equals negative 13. So sticking it all in the formula, we've got minus b at the start, so minus 2, plus and minus the square root of b squared, so 2 squared, minus 4 times 3 times negative 13, and that's all over 2a, which is 2 lots of 3. I'm going to type in 2 times 3. There we go. Right, so got to be very careful here, because there's a negative c value. What's going to happen is that number, that 4ac part, is going to be negative, but because we're taking it away, it's going to turn that into a plus. Now you've got to be careful. If you type this in wrong and you do forget to put the negative in or something like that, you're going to get an error on your calculator screen, which normally says syntax error or error. Okay, and that will be because you have got a negative number underneath the square root there. Now this can happen if there's no solutions, but obviously if we are looking to get a solution here in this type of question, we shouldn't be getting an error, and you can't square root a negative number. So just be very, very careful if that does come up. It just means you've probably ended up with a negative under there, which is unlikely to happen on a question like this. So right, I'm going to type this in. What I'm going to do is I'm going to do the plus version, and then I'm going to do the negative version. We'll have a look at them both separately. So on my calculator screen, I've got minus 2 plus the square root of, I'm just going to type it in as I see it, 2 squared minus 4 times 3 times negative 13 all over 6. And again, let's type that in, fraction button, negative 2 plus the square root of 2 squared minus 4 times 3 times negative 13 onto the bottom of your fraction, 6 equals, and turn it into a decimal. So we've got 1.774851773, and let's round that straight away. We get 1.77 as our first solution there. So there we go. There's our first solution. And then having a look at our second one. Let's see what we get for this. So we've got the same equation up there, but with the plus. So with the plus, but with a takeaway. So take away 2 squared minus 4 times 3. Oh, that's a weird 3 times negative 13, and that's all again over 6. And let's see what we get for this one. So back into your calculator, don't delete anything, just delete that plus, swap it for a minus, and again turn it back into a decimal. So you get minus 2.44151,844. And just make sure you do always write down all the decimals before you round it here. But rounding this to 3 significant figures, we get minus 2.44. There we go. So obviously, hopefully you followed along with me there. Do check that you're getting the same answer as me on your calculator. Just lets you know that you are typing it in right, and obviously you can have a look and amend it if it's not coming up with the same answers there. Okay, so it says write this x squared minus 8x minus 4 in the form x minus a squared minus b, where a and b are integers. So it doesn't say complete the square, but that there is completed square form. Okay, so that's what we're going to do. We're going to complete the square, and then it says hence find the coordinates of the turning point for the graph with equation x squared minus 8x minus 4, the same one that's up there. So all we're going to do is do exactly the same thing, completing the square, and then find the turning point. So I'm going to do it from this one below, but this time it's a minus 8 there. So when I halve that, it'll just be minus 4 in the bracket. There we go, squared. Always in that form, so we've already got a there. A is going to be 4. Now, just thinking about obviously expanding this, the final multiplication we do in a double bracket will be negative 4 times negative 4. That would give us 16. And we don't want 16, we want that negative 4 there. So in order to get to negative 4, we would have to subtract 20 to get to negative 4. So it's minus 20 at the end there. So there we go, A is 4 and B is 20. Now, in order to write the turning point, we're going to take exactly the same approach. Look, we flip the sign for the minus 4, so our x-coordinate is positive 4, and our y-coordinate is just this number at the end, minus 20. There we go. So the inverse function of x just means essentially what is the opposite or the reverse of this function. Now, the function at the moment, 3x plus 4, just means that whatever number you put in, it gets multiplied by 3 and then you add 4. And if we think logically, the reverse of that would be taking away 4 and dividing by 3. But let's have a look at a process for actually working out a method for how we could actually go about writing this expression out for this inverse function. Now, it's just personal preference. There are lots of ways of doing this. This is just the way that I like to do it. Now, instead of writing the function of x equals 3x plus 4, I like to just write y equals 3x plus 4. So I write y equals 3x plus 4, and now what I do is I rearrange it to make x the subject. So if I want to make x the subject, first thing that I do is I'm going to have to take away 4 here. Obviously it's just rearranging equations, so you can always have a look at my video on rearranging equations. But minus 4 from both sides would leave you y minus 4 equals 3x. And then to get x as the subject, we would divide by 3, and we'd get y minus 4 all over 3 equals x. Now obviously the y I only put in place there just to help me rearrange it. Obviously this isn't a very nice piece to rearrange, f of x, okay, so it's just easier just to replace it with a letter. And what we're going to do here now is just swap the x and y over to put the x back in, and that would leave us with x minus 4 over 3 rather than y minus 4 over 3, and that equals the inverse function of x. Okay, and think back to the logical idea there. We said x would you to reverse timesing by 3 and adding 4, you would take away 4 and divide by 3, and that's what's shown there in the inverse function, x take away 4 and then divide by 3, and that is our inverse function. Okay, so all we're going to do is write y equals instead of f of x, make x the subject, and then swap x and y. So 3 little steps there with some rearranging. Let's have a look at another one. Okay, so this question says, given that f of x equals 2 brackets x plus 2, work out the value of f minus 1 with a 10 in there. So that f minus 1 still means the inverse function, but with a 10 in there means it's going to want us to do something with that in a second. We'll talk about that once we get the inverse function. But first things first, we can see this inverse f, so let's find an expression for the inverse of f.
Now straight away we've got some brackets there, so we need to expand these brackets. So let's expand that straight away when we write y equals. So y equals 2 times x, which is 2x, and 2 times 2, which is 4, so plus 4. And let's find the inverse function. So subtract 4 from both sides, y minus 4 equals 2x. Divide by 2, we get y minus 4 over 2 equals x. And let's write our inverse function. So f minus 1 of x equals x minus 4 rather than y minus 4 over 2. Now whenever you're given a number in the brackets here, it just means it wants you to replace x with the number. That's why it says work out the value. So all I'm going to do is I'm going to sub in x equals 10 into my little expression here. So I've got x minus 4 over 2, and that's going to become 10 minus 4 over 2. 10 minus 4 equals 6, so it's 6 over 2, which gives me a value of 3. Okay, so find the inverse function and then sub that number in. There is another process to actually go about solving this, but I think it's a good process just to write out the inverse function and then sub it in, because there's two elements of the maths going on there rather than applying a little trick here.
Okay, so here we're looking at the triangular numbers. Now it says here the triangular numbers are 1, 3, 6, 10, and then the sequence continues. It says the nth term of this sequence is a half n brackets n plus 1, where n is the position within the sequence. So it says find the 200th triangular number. So to find the 200th triangular number, we just substitute it into our nth term, which we've got just here. So we would do a half multiplied by 200 to start with, and then that is going to be outside the bracket where we have 200 plus 1, and ultimately we're just going to multiply those as well. So a half times 200 would give us 100, and then inside the bracket we've got 201. So all we actually have to work out here is 100 multiplied by 201, which is going to be 201, and an extra 2 zeros there, which is 20,100. And there we go, that would be our final answer.
Okay, so this one's slightly more complicated because as you can see at the top, look, we've got £360 shared between Abby, Ben, Chloe and Dinesh. So there's 4 people in this one. So let's have a look. It says the ratio that Abby gets to the amount Ben gets is 2 to 7. So we've got Abby, we've got Ben, we've got Chloe and Dinesh. And it says Abby to Ben is in the ratio 2 to 7. And it says Chloe and Dinesh each get 1.5 times the amount that Abby gets. So both of these people here are both getting the same amount. They're both getting times 1.5 the amount that Abby gets. And 2 times 1.5 is nice and easy for us to work out. Half of 2 is 1, added on gives us 3 for both of them. And there we go. And then all we've got to do is split it in a ratio just in the same way that we have done before. The total of all those parts, if I do this below, if we add them all together, we get 15. So we've got 15 parts equaling £360. And then again, we can divide that by 15, and 360 divided by 15 gives us £24. So we've got that 1 part equals £24. There we go. And it says work out the amount of money that Ben gets. Well, Ben gets 7 of the parts. So if Ben's going to get 7 of them, Ben gets 7 lots of the 24 quid, which is going to be in each pile. So 7 times 24 gives us a final answer of £168. And there we go. And there's our final answer there. And again, we could work out how much they all get. Abby gets 2 of them. So 2 lots of 24 is 48. And then Chloe and Dinesh both get 3 parts, and 3 times 24 is 72. So we could do that. And then again, you could add them all up and check that they equal 360. But again, we're going to try and minimise the amount of working out we do here. So just straight away getting the amount that Ben gets. Okay, so this question here looks like a 3-part ratio. We've got the points A, B, C and D line order on a straight line. We've got A to B, B to D is 2 to 5, A, C, C, D is 4 to 7. And we want to find the ratio A to B, B to C, C to D. So it looks like, and it is going to be a 3-part ratio the way we look at it, but it looks like we're going to have to try and find some sort of crossover. Now, if you have a look, A to B is not in either of the other ratio. B to D is also not in either of the other ratios, so we've not got a crossover. So we're going to have to think about this slightly differently. Now it does say that they lie on a straight line, so if we just imagine this line, let's just imagine, here it is, here's a line, we've got A, B, C, D, and let's just label this up. So we've got A, B, C and D. Now it says the ratio A to B, B to D is 2 to 5. So that's this bit here, and I'm going to do this in a different colour. We've got A to B there, and that's 2, and then B to D to the end 5. Then we've got the other ratio that's given to us. We've got A to C, which is 4, and we've got C to D, which is 7. Right, so we haven't got a crossover, but we have got totals. And what we're going to have a look at is if we have something like this sort of scenario where we can draw a little picture, we can actually just combine both these ratios together by looking at them if the totals add up to the same. What I mean by that, look, is 2 and 5 gives us a total over here of 7. The other one, 4 and 7 over here, gives us a total of 11. Now, if they both had the same total, this would make this problem a lot easier. So let's think, what's the lowest common multiple of 7 and 11? Well, that is 77. So to make these numbers out of 77, I would have to times the top one by 11 and the bottom one by 7. And that would give me new numbers here on my number line. So if we change this, look, we've got 22, and we times that by 11, and here we've got 55. And on the bottom there, 4 times 7 is 28, and 7 times 7 is 49. Now that they have the same totals, we can pretty much just get the readings from our picture. So A to B, we've got up here 22, and that's the first part in our 3-part ratio there. So let's have a look. We've got A to B, which is 22. Now we're looking at B to C. B to C we can't find because it's crossed over on the other two, so there's no way we can get that at the moment. But then C to D, we've got that, that's given to us down here. C to D is that 49. So we've got 49 at the end there, we're just missing the one in the middle. And here's a bit of an idea of how do we actually find that number in the middle. Now we know that the total over here had to add up to 77, that's what we did, we made these both add up to 77. So this total that we're looking at has to add up to 77, okay, just like those other two. These have to add up to 77. So what have we got at the moment? We've got 22 and 49. Let's add those together, see what we've got so far. 49 and 22 make 71. So to get from 71 to 77, we would have to add in an extra 6. And there we go. And there's our 3-part ratio here from a diagram. So something a little bit different, okay? You do have to draw a little picture for this. I think it's probably quite difficult unless you draw a picture, but there's just something a little different just to finish this off when we're looking at this combining ratios, and rather than looking at a crossover, we're looking at the total between them so that we're able to combine them together and have a look at these sorts of missing distances in the middle. Okay, so in this question we're going to have a look at some percentage increases and decreases. So it says here at the end of 2015 the value of Alice's house was £240,000 and the value of Carl's house was £170,000. At the end of 2018, the value of Alice's house decreased by 20% and the value of Carl's house increased by 30%. Who's had the greater value at the end of 2018? And again, you must show how you get your answer. So again, we're going to use a calculator method here, and we'll start with Alice. So if her house has decreased by 20%, again we could use a multiplier of 80% because it's gone down by 20. So if we multiply by 0.8, that's going to straight away give us the value of the house. It's going to decrease it by 20% for us. Now if we do that, that comes out as 192,000. So Alice's house has gone to £192,000. Now when it comes to Carl's house has actually gone up in value. So we wouldn't multiply that by a 0 point number, but instead we would multiply it by 1 point, and for this it's 30, so 1.3. That's going to increase it by 30% for us. So if we again just type that in on the calculator, that comes out as 221,000. So straight away we can see by our working out there that Carl's house has the greater value at the end of 2018. So as it says here, whose house has the greater value, we would just make the statement like before, Carl's house has the greater value. There we go. And again, that is backed up by our figures. So we don't need to put exactly how much more or less Alice's is worth. We can just say that Carl's house has the greater value, and that is backed up by our working out as shown above. Okay, so this question here, it says Tame Valley is a company that makes yogurt. A machine fills 20 pots with yogurt, and in 1 hour it fills a total of 15,000 pots. How many seconds, or work out how many seconds the machine takes to fill a tray of 20 pots. So in this question here, we've got one piece of information that is mentioning
hours and one that's mentioning seconds. We've got in 1 hour it fills 15,000, but it wants us to work out how many seconds it takes to fill one of these trays. So we've got a little bit of time conversions going on. So to start with, what we could work out here is actually how many times it's going to have to fill up this lot of 20 pots. So in the hour it's going to fill up 15,000, and each time it's filling up 20. So if we do 15,000 and we divide that by 20, it's going to tell us how many times it actually has to fill up this these 20 pots. So 15,000 divided by 20 comes out as 750. So essentially it has to do this 750 times, and each one of those 750 times it's filling up 20 pots. So that is going to take 1 hour, but we obviously want it in seconds. So if let's turn the amount of, let's turn the 1 hour, I was going to say the amount of hours, but we've only got one. So let's turn the 1 hour into seconds. Now in 1 hour, there are 60 minutes, and in each one of those minutes, there are 60 seconds. So if we do 60 times 60, that tells us how many seconds are in 1 hour. And that's nice and easy for us to work out. 6 times 6 is 36, and add 2 zeros. So in total, to fill up these 750 times, it's going to take 3,600 seconds. So to work out how long it's going to take to fill up one of those, we'll do 3,600, the total amount of seconds, and we'll divide that by the 750 times, and it's going to tell us, and it gives us here 4.8 seconds, and that's how long it's going to take to fill up each tray of 20. And that'll be our final answer there. And that is just being very careful with your time conversions and getting that 1 hour written in seconds. There's a lot more words in this question. It says it takes 8 machines 9 days to complete a job. On the first day 3 machines are used, on the second day 6 machines are used, and for the remaining days 7 machines are used. I just realised that says are's used. There we go, let's get rid of that. It should just say are used. How many days does it take to complete the job? So first things first, we've got this first bit of information here, 8 machines and 9 days. So we can work out one machine, so 8 times 9 gives us 72 days in total for this job to be completed by one machine. Now it says on the first day 3 machines are used, so that's 3 days worth of work there. That's only on one day, okay, but on that first day, let's just label this on the first day, there's going to be 3 days of work done there, okay, so 3 days. There we go. So that's one day, but 3 machines. So in total, that's 3 of those 72 days that were going to be done there if it was one machine. It says on the second day, 6 machines are used. So on the second day, we've got 6 machines. That's only for one day again. So it's just going to be 6 days of work. Again, it could say for 2 days there. That'd be 12 days, but it's only one day. So 6 machines, 6 days of work there. And for the remaining days, 7 machines are used. So in total, we've done 9 days worth of work there. Okay, the 3 and the 6, 9 days of those 72 have been done. So if we take away those 9 days, how many actual days do we have left there? And 72 take away 9 leaves us with 63 days of work that needs to be done. Okay, so we have 63 days that need to be done. Right, so it says for the remaining days, 7 machines are used, and we've still got 63 days of work to be done. Technically 63 days, but we are going to be using 7 machines, so it's going to be 7 times faster than if it was just one machine. So let's divide that by 7, and 63 divided by 7 leaves us with a remaining amount of days there of 9. So there are going to be 9 days done in those remaining days where we have 7 machines. Now we've not quite finished the question here, because not forgetting we did have the first day where we used 3 machines, the second day where we used 6 machines, so 9, add those additional 2. So add the extra 2 there from above, would give us in total 11 days that it's going to take to do this job. Okay, 2 days where we've got the 3 and 6, and then 9 additional days where we are using 7. Okay, so looking at some pressure, force and area. It says here a force of 70 newtons acts on an area of 20 centimetres squared. It says the force is increased by 10 newtons and the area is increased by 10 centimetres squared. Does the pressure decrease by less than 20%? And you must show how you get your answer. So if we work out the pressure to start with our original numbers, we have 70 newtons, which is our force, on an area of 20 centimetres squared. So if we put that into our formula, we've got 70 divided by 20, and that gives us an answer of 3.5 as our pressure. Now, if we look at increasing the newtons and increasing the area, instead of having a force of 70, we'd have a force of 80. And instead of having an area of 20, we're going to have an area of 30. So if we work out 80 divided by 30, we get an answer which comes out as 2.6 recurring. So it has gone down, so we can see it has decreased. But the original pressure there was 3.5. So does it decrease by less than 20%? Well, if we look at that actual pressure there of 3.5, we work out 20% of that, and we can do that by just multiplying it by 0.2, or we could use a percentage multiplier, or a sort of decrease multiplier of multiplying to reduce by 20%. That multiplier that we can use if we take away 20% from 100% is multiplying by 0.8. So if I multiply by 0.8, and again you don't have to use a multiplier, you could just work out 20% and take it off, but this is a nice quick way of working it out. You get the answer 2.8. So if we were to have decreased it by 20%, it would have gone down to 2.8. And as we can see, it has actually gone down to 2.6 recurring. So it's gone down by more than 20%. So this question says, does the pressure decrease by less than 20%? Well, no, the answer is it would decrease by more than 20%. So we would have our working out there, but we would say no, it decreases by more than 20%. And that would be our final answer. So when you've got something like this, we do not have to say exact figures here, but it's fine for us to say it decreases by more than 20% as we have the correct working already shown next to the question backing up that statement. It says here, the diagram shows the planned front elevation and side elevation of a solid prism drawn on a centimetre grid. Draw a sketch of the solid prism, give the dimensions of your prism on your sketch. Now this isn't the nicest of ones to draw, it's actually quite similar to one that I drew earlier. Now you can see from the front, okay, which you can also sometimes imagine as the side, it sort of has this like look as if it's almost like a little step. Okay, obviously not a full set of stairs, but like a little step. So from the front there we could sort of draw this in. There we go, obviously it does require you being able to draw for this, which is, there we go, not the easiest, but there we go. That from the front we've got this sort of shape going along like this, there we are. Let's have a go. I'm trying to draw this as best as I can. There we go. There we are. We've got this sort of shape going on, okay, sort of like a little step. Now obviously that matches on the plan as well, okay, just check this out. You've got the face there and the face here, and on the left there you've got the green face, that's 3 along there, and the green face here. There we are, so we can see those. Hopefully obviously you can already see obviously this face here is matching this one here, and then you've also got the side, and I'll try and draw this in. You've got this one down here from the side which matches this face here, and we've got one more. I'm going to run out of colours though. What have we got? Not very nice colours there, let's go with blue. Right, okay, so you got this one here that matches that one there. There we go. And that is how we're going to draw this little sketch of this prism. Okay, obviously it does say we need to add the dimensions on as well, so we just want to have a little look. So along the front here, that goes along 5. So I want to put 5 centimetres along here. And it goes up by 4. There we go, so we'll put that on the side there as well, 4 centimetres. Along the pink face there, we've got 3 along, so that's going to be 3 centimetres. We've got a few other dimensions that we could add on as here. We've got this one here, which is 2 going up, and this one here, which is also 2. So we'll put that on as well, so 2 centimetres there. Just get rid of that bit if I can. There we go, 2 centimetres there, and also we have 2 centimetres up there. Is there any more that we wanted to? We could add on. We could probably add on these ones as well. We've got 3 there, which is up here, 3 centimetres, and we've also got, it's hard to draw in now, but that one there, which is 2 centimetres, so that's 2 centimetres there as well. There we are. That is literally every single dimension we could put on there, onto that particular prism. So just sort of filling it with all of the different dimensions that we could possibly put on that diagram. But there we go. That is how we go about drawing that one. Hopefully that helped a little bit with the colours being added on. Obviously it does require you just to be able to think about these shapes and being able to draw a little 3D sketch. So some of them are quite nasty. This one in particular is not the nicest to actually be drawing, but obviously you just got to try and draw it as
as best as you can. That's why it does say in the question, draw a sketch, okay? So obviously using a pencil and a ruler if possible, but just trying to draw it as best as you can, okay? And not stressing too much if your diagram doesn't look absolutely perfect, okay? So just as best as you can, that's what a sketch is.
Now this one here is asking us to work out the volume, and you can notice that we've not been given the height. But you might also notice that inside the cone there, you can see that there is a right-angled triangle. Now, if we can make a right-angled triangle, which we can inside a cone, then we can perhaps use a different element of maths. And you should know that when we are using right-angled triangles, perhaps we might use Pythagoras and perhaps we might be using some trigonometry. Now, just for this one, we're not using any angles, we are just looking at a length, so we can actually use Pythagoras to work this out. And if I was to draw this triangle to the side, you can see that we have the hypotenuse, which is 12.6, and we have one of the shorter lengths, which is 5.7, and we want to work out this length here. So when we are using Pythagoras, we are going to do both the numbers squared. We're either going to add them or take them away from each other. In this case, we'll do a takeaway because we're looking for a shorter side, and then we'll square root our answer. So to get the height, we are going to do 12.6 squared, take away 5.7 squared, and then square root the answer. And if you're not sure on Pythagoras, again, I'm going to link that for you so that you can have a look at some Pythagoras if you need to. So if we type that into our calculator, and you can type it in one go, so 12.6 squared, take away 5.7 squared, we get an answer, and it comes out as 11.23699,248. Now that is now our height, so we can actually go about working out the actual volume of this cone now. But you've got to be careful because obviously that height there is quite a long decimal and we don't want to round it until the very end, so I'm going to leave that on my calculator. Now we can actually go about working out the volume, so I would do 1/3 multiplied by pi multiplied by the radius squared, which is 5.7, so times 5.7 squared, multiplied by this long decimal, so 11.23699,248. There we go. I'm going to leave that number on my calculator so I don't have to type it back in. So I've got 1/3 multiplied by pi multiplied by 5.7 squared, and then I'm just going to press times the answer, and that will put that previous answer in, and I will get a final answer here of 382.3212,343. And again, finishing this question off, we just need to round it to 2 decimal places, so after the 2, and that is going to give us a final answer here of 382.32, volume again, so centimetres cubed. And there we go, there's our final answer. So as you can see, even if we don't have the height, we can use other elements of maths. In this case, we were using Pythagoras to work out that height and therefore work out the volume. Okay, so this says work out the surface area of the hemisphere and give your answer to 2 decimal places. Now, if we're going to work out the surface area of the hemisphere, bearing in mind if this was volume of a hemisphere, it would be nice and simple. You would just work out the volume and then you would just divide your answer by 2. But when you're working out the surface area, it's a little bit more complex because we're not just looking at half of the surface area of the full sphere, if it was a full sphere, but we are also having to include the surface just here, which is a circle. And the area of a circle, let's not forget, is pi r squared. So we've got another formula we're going to need if we are looking at the surface area of a hemisphere. So we can work out both these pieces, but we can start by looking at the circle. So to work out the circle, and if we just label this as the circle, we're going to do pi r squared, which is pi times 8 squared. So pi times 8 squared, you can work that out on the calculator, and that comes out as 201.0619298. I'm going to leave that full answer there as well because when we add that to the remaining surface area around the outside, we don't want to get any rounding errors before our final answer. So now on to the curved surface area, okay, the curved part around the outside, so I'll label this as the curved. Now there are 2 ways that you could do this. Either you take the original formula, which we know is 4 pi r squared, and you work that out and divide it by 2. Or you can actually just divide the formula by 2. So what I could actually do is just take 4 pi r squared, divide that by 2, and instead we get the formula 2 pi r squared. And that is absolutely fine for you to use as well. Okay, so that might just save you a little bit of time in terms of the process, because instead of using the formula and then halving your answer, you're just going to straight away get half of that answer. So if we use that formula instead, as it is half of a sphere, then we, instead of doing 4 pi r squared, we're going to do 2 times pi times 8 squared. And if we type that in, let's see what we get. 2 times pi times 8 squared, and we get the answer 402.1238597. And there we go. And that is the curved part of the hemisphere. Now obviously we are looking at the overall surface area. So we want to take both of those pieces there, the 201 and the 402, and add them both together. And if we add them both together, we're going to get to a final answer. So if we write that working out down, we've got, and let's just write this down just below, we've got the 201.06 with a few more decimals, and we're going to add that onto the 402 number, which is 0.12 with a few more decimals, and let's see what we get when we add them together. So I've got the 402 already on my calculator, so I'm just going to add the 201.06192998, and I get a final answer there of 603.1857895. There we go, and that is my final answer. Again, just looking at the question, because it says round it to 2 decimal places, so I just want to chop that after the second decimal, which is after the 8, so 5 afterwards, so it is going to round up. So my final answer, and I'm going to have to write this at the top, is going to be 603.19. Now we're looking at surface area, it's in centimetres, so we would say centimetres squared. And there we go, there is our final answer for the surface area of a hemisphere. Okay, so moving on to a slightly different question. Now, as with all of these questions, even though this isn't a particular practice question for you to have a go at, I would encourage you to just pause the video and have a go and think about why you would struggle to work this out, if you would struggle with it at all. And this particular question is actually quite a tricky one. It says that ABCDE is a pentagon. Work out the area of ABCDE. Again, those letters ABCDE just refer to moving around the shape ABCDE, finishing the connection, and it forms the pentagon. So in order to work out the area of this, we need to split it into different shapes. Now there are a couple of different ways that I can think of as to how you could split this. You could split it down the middle potentially, and that would make 2 trapeziums either side. Or potentially you could split it across the top, and that would make a rectangle and a triangle. Now I would assume that the rectangle and the triangle would be easier than splitting it into 2 trapeziums, but let's just have a go and see what happens. So for this one here, the easy area to work out is obviously the area of the rectangle on the bottom, and that is just going to be doing 4 times 8. So 4 times 8 is 32, and that gives us an area of 32 centimetres squared. Now we have to think about the area of the triangle. We know for the area of a triangle, you need to do base times height, and we know that the base of the triangle is 8 as it matches the base of the rectangle down on the bottom here. But we also need the height of the triangle, and unfortunately we don't have that height. So we're going to have to think about how we're going to get the height. So let's move this 8 to the side, and let's just think about that length there, which is the height. So how would we go about getting that? Now looking at what we have there, we've now split it up into 2 right-angled triangles. If I could draw this right angle in here as we are looking at the perpendicular height. And down here, if we split up that 8, which might just help us here, we would have each triangle on the left and the right having a base of 4. Now does that help us to work out the height? And hopefully you've spotted that in order to work out a missing length in a right angled triangle, you would have to use Pythagoras theorem. So to use Pythagoras for this, that is obviously involving a whole new topic now. And again, I will link Pythagoras theorem for you if you're unsure on how to go about using Pythagoras. But to use Pythagoras theorem, we square the side lengths that we have on the 2 other parts of the right angled triangle, and then we're going to add or subtract depending on whether we are looking for the hypotenuse or not. In this question, we're not looking for the hypotenuse, we're looking for a shorter side, so we would do the square root of, and again I'm doing this in one step, but 5 squared take away 4 squared. Again, you can do 5 squared take away 4 squared and then square root it, but if we just do that in one step, we've got the square root of 25 take away 16, which is the square root of 9, which comes out as a length of 3. So the height of triangle has a length of 3. That is now going to allow us to work out the area of that triangle because we have the height. So it's up to you. You could work out the area of one of those triangles and then double it, or we could just go back to working out the area of the full triangle here, which is going to be the base times height divided by 2. Now the base of the whole triangle was 8, so we have 8 multiplied by the height, which is 3, and then we're going to divide that by 2. And that comes out as an area of 12. Again, it's in centimetres, so centimetres squared. So we've got the area of the rectangle, which is 32, and we have the area of the triangle, which is 12 centimetres squared. So to finish this question off, we would add them both together, and that is 32 plus 12, which comes out as an overall area of 44 centimetres squared. And there we go, that is our final answer for working out this area. So as you can see with this question, I've already introduced where we may have to work out the area of a compound shape, and it may actually involve us to use something like Pythagoras. So there's another example of a compound area question where we have a different topic being involved, which is the very nature of these problem-solving type questions.
Okay, so in this question it says two cylinders are mathematically similar. The height of cylinder A is 3 and the height of cylinder B is 9. The volume of cylinder B is 540 centimetre cubed. Work out the volume of cylinder A. So again, there's no pictures, again, which it may or may not give to you, but I can easily draw one and it doesn't have to be perfect. So let's call this cylinder A, and let's call this one cylinder B, which I'm going to draw just a little bit bigger there. Because I can see that the height of that is 9 rather than 3. Again, this isn't to scale, it's just to give you a little visual idea. So this is 3 centimetres as the height of A, and this is 9 centimetres for the height of B. Now it does also give us another piece of information, so let's write that on. It says 540 centimetre cubed for the volume of B there. Okay, just making sure you label that appropriately. Okay, it's always a good idea to highlight some of the information. Height of A is 3, height of B is 9, and then the volume of B is 540. And we're going to work out the volume of A. So again, we just need to work out what our scale factor is. Now again, we've got 3 and 9 there being the heights. So I can work out my length scale factor by doing 9 divided by 3. Again, the bigger one divided by the smaller one. And 9 divided by 3 is 3. Now again, on this case, I'm going to be thinking about, do I want my area scale factor or do I want my volume scale factor? Now the question here is asking us to work out a volume, so I can ignore area, and to get from length to volume, in this case here, we would cube it. Again, just thinking about the units within that, it's centimetre cubed. So to get from length to volume, you would cube it. So our volume scale factor is going to be 3 cubed. And 3 cubed, we can actually work that out. 3 cubed, 3 times 3 times 3 is 27. So that's the scale factor we're going to use here when we're looking at volume. Right, so we are working out the volume of A. So I'm going from the big one down to the little one. So I'm not going to multiply this time because the volume is definitely getting smaller. And all I have to do differently here is I just divide by the scale factor. So I divide by 27, because thinking about what I said earlier about it being an enlargement, it just means the volume's getting 27 times bigger. So if we're going back down to the smaller one, it has to get 27 times smaller. Now 540 divided by 27 without a calculator isn't too bad. 27 goes into 54 twice, so it goes into 540 20 times. So my answer for this one is going to be 20 centimetres cubed. And that's our final answer there. So let's just write that down here this time. So my final answer is 20 centimetre cubed, being the volume of A there. Okay, so we have a slightly different question here because we have some overlapping triangles. So it says in the diagram below that PQ is equal to PR. So we know that this length here is equal to this length here. So therefore, straight away, we know that this is an isosceles triangle. So we'll think about that later. It says S is the midpoint of PQ. So if S is the midpoint of PQ, this line here is the same length as this line here. And that is going to apply on the same side, as this length here is the same length as this length here. So again, we'll think about that in just a second. It then says prove that triangle QTR is congruent to triangle RSQ. So Q to T to R is this triangle just here, and overlapping that is the other triangle where we have RSQ, and R to S to Q
is just there. So as you can see, they overlap, but hopefully you can see them relatively clearly, and we're going to have a go at proving this one. So to start with, can we see anything that's the same in both? And I think personally the easiest bit to see here is that they both have the same base length. As they both share the same line, that's an easy bit of proof for us to say. So for the first one, I would say QR is the same length in both. There we go, so that's a nice easy one. Same length in both, and that has already proved a side. So we've got our first side proved. Let's think about what else we could prove. Well, another thing that we mentioned was the fact that this line here was the same length as this line here, as it says that that was a midpoint. And we know that because it's an isosceles, if it's a midpoint on both, then both halves must be the same length on either side. So I could also say, and this is a relatively nice one on this one as well, that Q to S is equal to T to R. And we just need to think about how we would give our reason, because both lengths are the same and both are midpoints. Okay, both, or halves I could say, both halves of the same length side. And you could write that in different ways, but I've just tried to write it in an obvious way there. So both halves of the same length of side. And again, that is a side. So we've got two sides already. We just need to think about what else we can find. And again, it goes back to thinking about the fact that it's an isosceles. We know if this is an isosceles, where these two lengths are the same length, we know that in an isosceles, base angles are equal, as we have our isosceles triangle. So for the final one there, I could also say that the angles there are the same as it's an isosceles triangle. So I can say that angle, and what is it, PQR is equal to PRQ. There we go, and those angles are going to be equal. Let's just get rid of that, that doesn't quite go over the R there. There we go, PRQ. So they are equal because base angles in an isosceles are equal. And it's quite awkward having to write it all, but very important that you write it all down. So base angles in an isosceles are equal. So we've got our 3 points there, that was another angle. So just thinking about what we have an angle in between two side lengths. So therefore, triangle QTR is equal to triangle RSQ. And our reason there is because we have an angle in between two sides. So that is going to be SAS. And there we go, that finishes off our question. So this question here says the table gives information about the languages studied by a group of Year 11 students, and it says that 30 study French, 37 study German, and 53 study Spanish, and it says draw an accurate pie chart for this information. So the first thing we want to do is add up all these numbers. So if we add up 30, 37 and 53, let's have a look, that adds up to 120. And I always just write that down over here somewhere near the table, just so I know what the total is, and the total there is 120. So in order to get this to 360, either you just have to think about that in your head, what you multiply 120 by to get to 360, or we could just do 360 and divide that by the total there, which is 120. So 360 divided by 120 is 3, meaning that we're going to have to multiply all of these by 3 to get the angle in each portion of the pie chart. So if we multiply them all by 3, and we'll just write times 3 next to them all, there we go, times 3 times 3 times 3, that would mean that 30 would become 90 degrees, and these are our angles now. We would have 37 times 3, which would be 111, so that would be 111 degrees, which is a bit of an awkward one to draw, and 53 times 3 would be 159, so that is 159 degrees. Now that is the main bit of our working out now. We know all of the angles that we need to draw, we just actually need to draw them on correctly. So when you've got your pie chart drawn like this, if it's given to you, if not, you're going to have to use a compass just to draw a circle. And if you're making notes on this, I would definitely do that. Just get your compass, draw a nice circle, just make sure that you know where the centre of that circle is, so that you can draw this nice straight line going up so you have a place to start from. So let's start with drawing on this French one, which is 90 degrees. And we can put them all in at the same time, but let's do the first one. So get your protractor, pull it over the top of the pie chart, make sure that little crosshair in the middle is right on the centre. And there we go, I'll just do that really nice and carefully. And then you also want to rotate your protractor so that the guideline where it starts at 0 is lined up with the line that you're starting from, which is the one that's vertical. So there we go, that's nicely lined up. So I want to mark on 90 degrees. So I'm just going to mark the 90 degrees over there. There we go, pull your protractor out the way. And then with a ruler and a pencil, from that central point, draw a nice line over to that. And you can obviously do it a little bit shorter, just to the edge of the pie chart. And there we go, that's your 90-degree angle. Now you can move on to the next one. But before you do, what I tend to do is I normally tend to label that section. So I'm just going to put French in there. So I'll put French in, and I'll also put the degrees in there, 90 degrees. You could also put the 30 in there as well, but just to keep it a little bit simpler on the screen, it's going to leave it as French with the 90 degrees. Okay, so putting your protractor back onto the centre. Now we just want to rotate the protractor round so that the 0 is lined up with our new line, so we can carry on from that point. And again, I'm using the outside numbers. And now we need to do 111 degrees. So past the 90, 110, 111 is just past that, and you're going to have to just get it as accurate as you can. There we go, there's 111 for me. Again, just pull that protractor out of the way, and we can draw in a nice straight line again from the centre. So from the centre, ruler and a pencil, join it up. I'm just going to shorten it a little bit. There we go, you can do that a little bit easier when it's not on a screen, but there we go. Using your ruler and a pencil, I'm just going to label that, so that would be German. And that was 111 degrees. There we go. And the last part of the pie chart here, which as we only have one left, is Spanish. So we'll label that as Spanish, and that is 159 degrees. A good bit of practice here that you should do is you should stick your protractor on, just measure that final angle there. So I'm going to flip it around the other way, measure to see if that's 159. Might be a little difficult for you to see on the screen there, but that comes out as around 159 for me. So I'm happy with that. It's an accurate pie chart. All of the angles match up to what I wanted them to. And there we go, there's your pie chart. Okay, so that's how you go about drawing it. That's how you get the angles. Remember, they've got to add up to 360. So that bit of working out there where I added up the total and did 360 divided by that total allowed me to see what I needed to multiply all those numbers by so that they all added up. And another good bit of practice that you could do is take those three numbers and just add them up, and you can actually see 159, 111 and 90 do all add up to 360. So we've definitely got it right. Okay. Okay, so we've got some slightly more numbers in this question and a bit more information. If you have a look at the first line, look, it says there are 20 men, 10 women and 10 children. So we've got 3 bits of information in this question now instead of 2. It says the mean score for the women is 15.6 in this competition. The mean score for the children is 9.2 and the mean score for all 40 is 11.2. So again, we are missing one of the bits of information there. Look, we're missing the mean for the men. So it makes sense that the next line then says work out the mean score for the men. So let's just start linking these up and start multiplying them out. So let's have a look. We've got 20 men, and that's not been given, we've not been given any means for that, so we're going to have to skip past that one. We've got 10 women, and it says the mean for the women is 15.6, so straight away we can times that by 10, so 15.6 multiplied by 10 gives us a total score for the women of 156. Then we're on to the next one. Let's have a look what we've got. We've got 10 children, and it says the mean score for the children is 9.2, so we can do that as well. We can do 9.2, multiply that by the 10 children, that gives us their total score of 92. Now the next one, and this is normally the one you just need to be careful on because this now tells us the mean for all of them. Now the total for all of them, look, we've got 20 men, 10 women and 10 children, so we've got 40 people in total. There we go. So it does actually say that in that last line there. It does say the mean score for all 40 people, but if it doesn't, just remember that's where you get it from. So it says all the 40 people's total mean is 11.2, so let's just times those together. We've got 11.2 multiplied by the 40 people. There we go. I'm just going to do this on the calculator just to speed things up a bit, and that gives us 448. There we go. So we've got our overall total there of 448, and we've got the women and the children's total. So we had to work out the total for the men now. We just need to do the overall total 448, and we're going to take away the 156 and take away the 92 and see what our total is now. So take away 156, take away 92,
and we're left with 200. There we go, and that there is the total for the men. Now we can finish off our mean again, just like before. Don't forget there are 20 men. So now we've got their total, 200. We can divide that by 20, and 200 divided by 20 is 10. There we are, and there is the mean for the men there. Right, let's just highlight that. There we go, there's our final answer. So there we go, that's how you do a reverse mean. You just multiply the mean by the actual amount of people that it relates to, or the amount of things it relates to, just depending what the context of the question is. And then obviously just use a bit of logic to find any totals that you're actually looking for, obviously before then working out the mean in your final step. So this question says, Rosie has 10 boxes of drawing pins. She counted the number of drawing pins in each box, and this table gives some information about her results. Now we can see in the table, we've got the boxes with 29 drawing pins there. There was 2 of those. The boxes with 30 drawing pins, there were 5 of those, and so on. 31 where there were 2, and 32 drawing pins, there was only 1. And it says work out the mean number of drawing pins in a box. Now we know hopefully when we're working out the mean, you add up the total of all the different boxes of drawing pins here, and we divide by how many boxes there are. And this question's nice, it actually tells us that there's 10 boxes, so we know that we just need to get the total and divide by 10. Now obviously this information is within a table, so we don't have our normal list, although we could actually imagine what we would do if we had a list. Now if we did have a list here, now 10's okay, but once we start getting to tables where there's 80, 100 things in the table, we won't want to do it in this particular way, but just so you have an understanding of how and why we do the process we do, we'll have a look at this first one. So we've got 2 boxes of drawing pins that have 29 in, so we'd have 2 29s, so 29 and 29. Then we've got 5 with 30 in, so 30, 30, 30. You can already see it's actually already a bit annoying having to write these all out. 30 and 30, there we go. We've got 2 with 31, and another 31, and we've got 1 with 32 in. So I could just give you this list here and say work out the mean, and what you do is you just add them all up and we would divide by 10. So with this particular table we could actually just take that approach, it'd be nice and easy to do so, but obviously as I said, as they get a bit trickier we're not really going to want to take that approach. But essentially we're going to have a look at what the totals of all the numbers are, and what we're going to do obviously because they're categorised, what we're going to have a look at is we're going to look at the total of these 29s to start with. Now there's 2 of them, so 2 29s, we could add those together and we get a nice total there, and that is 58, that total. Then we would have a look at the 30s and we'll add all of those up. We've got 30, 60, 90 plus another 2, 120, 150. So the total of those is 150. The total of the 31s is 62, and the total of that 132 there is 32, and then we can add them all together as groups. Now what we're going to do is we're going to take that away from the list and have a look at it from the table. So we'll get rid of all of that, and we'll do it from the table here. So we've got 2 29s, now all we have to do is times the 29 by 2, and that gives us their total there. So 2 lots of 29, we've already said, is 58. Then we've got 30 lots of the, well, 5 lots of the 30s, and that was 150. We've got 2 lots of the 31, that's 62, and 1 lot of the 32, and that gives us 32 as the total there. Now throughout these questions they could be calculator, they could be non-calculator. I am just going to use a calculator, although I've got to be honest, I think this question is a good non-calculator question, but as long as you know the process, obviously if it was a calculator question it would be quite nasty numbers, one that you wouldn't be expected to do without a calculator, but they could be non-calculator as well, and here's an example of one I think where this could be non-calculator. So let's have a look. Now we've got all these totals for each row, we can actually just add those all together. So 58 plus 150 plus 62 plus 32 gives us the overall total there of 302 for the total number of drawing pins in all these boxes. Now we already know we're going to divide by 10, as it says in the question up there that there's 10 boxes, but if we didn't actually have that piece of information we could find that because we've got the total frequency just here. And if we do 2 plus 5 plus 2 plus 1, we get a total of 10 boxes. So all we need to do to finish this question off, to get our value of the mean, is we're going to do 302, the total of all the drawing pins, and divide it by the 10 boxes. As you can see, that would obviously be why this might be a non-calculator question, because dividing by 10 is nice and easy. We just hop the decimal in and we get the answer 30.2 for our mean. So in terms of a process there, look, we times across, we get all the totals for each category, we add them all up and divide by how many things there are, and in this case the things is the 10 boxes, and we get that just by adding up the frequency column down here. So there we go, get the total, divide by the total frequency, and you have got your mean. Now it says Hannah is planning a day trip for 195 students and she has a sample of 30 where they want to go, and each student chooses a place. It says the table here shows the information about her results, so we can see that there's people that want to go to the theme park, the theatre, the sports centre and the seaside. And it says work out how many of the 195 students you think will want to go to the theme park. Okay, so we're just looking at the theme park here, which is just here. And it says state any assumption you make and explain how this may affect your answer. Okay, and we'll have a look at that a bit when we finish. First of all, let's try and work this out. Now there's a couple of different ways that we can do this. I'm going to discuss the non-calculator method to start with, as this is quite a nice non-calculator question. Now it obviously says that she takes a sample of 30 students. If it doesn't say that, we can get that from the total down here and we get a total of 30. Now in terms of the students that want to go to the theme park out of the sample, well, there are 10 students in the sample, so that is 10 out of 30 students. Okay, so that's 10 out of 30 that want to go to the theme park. And if we simplify that fraction, that simplifies down to 1/3, okay, dividing the top and bottom by 10 there. So what we can say is that we know 1/3 of the students, based on the sample, are going to want to go to the theme park. So if she's going to ask 195 students, then we just need to work out 1/3 of the 195 students that she's planning for. So we could work that out. We could do 1/3 of 195, and obviously if we're doing this without a calculator, we're going to want to use a bit of bus stop here. So 195 divided by 3, 3 goes into 19 6 times up to 18, remainder 1, and then it goes into 15 5 times. There we go. So our answer here would be 65 students, okay, that we are expecting to want to go to the theme park there. So that's obviously a little non-calculator method. It works quite nicely for this question here, but they're not all going to be non-calculator questions, so we could have to do this in a calculator way as well. Now if we've got 30 people in the sample, essentially we want to figure out how do we get that 30 to represent 195 students in a way. So how do we get from 30 to 195? Okay, we've got 195 that we want to go. So if we figure out how we can turn this and scale it up to 195, we can figure out how many 30s go into 195. So if I can do 195, I could divide it by 30. Let's do this on the calculator. And that equals 6.5. Let's just write that down. There we go. So essentially all I need to do is multiply all of these by 6.5, and that would get me to the appropriate amount. Now it only wants the theme park, but I could go and multiply them all, and 10 times 6.5 is equal to 65. There we go. So we can find it that way as well. Okay, just figuring out how many times that sample has to fit into the total amount. Sometimes that's not going to be very nice, as you might have spotted the one below. If I do 5 times 6.5, that would give me 32.5 people, and obviously we can't take 32.5 people, so you'd have to end up rounding some of these and sort of doing that appropriately, and it doesn't always get you the perfect answer for some of them, but it does here for the theme park. It gives us a nice whole number there. Okay, so two different methods that you can approach. One is just looking at, what fraction of the sample want to go to that place and then finding that fraction of the total. Or you can figure out how many times does that sample fit into the total amount. So that's what we did there. How many times did 30 fit into 195? And that meant that we just had to scale them up and multiply them all by 6.5 to get our total there. Now for the finishing part here, it does obviously state any assumptions you made and explain how this may affect your answer. I'm not going to write this down, but essentially we are assuming that the sample is going to represent the 195 students. Now obviously, and probably in real life, that's probably not the case. It's very unlikely that exactly 1/3 are going to want to go to the theme park. But in terms of how this may affect your answer, if we are wrong, okay, there could be more students that want to go to the theme park, and likewise there could be less students that want to go to the theme park, okay? So we are assuming that the sample represents all the students, and if we are wrong, there could be more or less students, and actually thinking about real life, it's more than likely there are going to be more or less, okay? But it gives us a good estimate in terms of how many students want to go to the theme park.
Okay, so for this question here, it says an electronic game can show red, blue, green or yellow. The table shows the probability that one of these colours will be shown, but it's missing the probability in blue. Now before I even carry on, I know I'm going to have to work that out. So we may as well go ahead and work that out, but it does say in part A, work out the probability that the colour shown will be blue. So in order to work this out, we know that these probabilities have to add up to 1. Okay, now at the moment, if we add together what we do have, we've got 0.15, 0.48 and 0.24, and in total they add up to 0.8. So if we take that away from 1, it leaves us with what's left over, and that comes out as 0.2. So the probability of blue is 0.2. Now that's fine to give your answer as a decimal, but of course you could give your answer in a multiple of ways here. You could say that it was 2/10, 1/5, or even 20%, and that's absolutely fine, but when the question is mentioning decimals, I will always give my answer in the same form that it's given in the question. Part B here, it says Janice is going to play the game 50 times. Work out an estimate for the number of the times the colour will show yellow. Now, obviously yellow means we need to use this decimal here this time, which is 0.24. Now again, there's a couple of different ways of working this out, but 0.24 as a percentage is 24%. So you could work out 24% of 50, and that would give you your answer. As well as that, you could treat it as a decimal or a fraction. In this case, where we're using a calculator, using the decimal is much easier, because to work out 24%, you just multiply by 0.24, which is the decimal that we're given. So to work out our answer, we'd just take the 50 times that she's going to play the game, we'll multiply it by the decimal related to the colour we're looking for, which is 0.24, and this straight away gives us our answer, and that answer is 12. So in terms of our estimate here, we'll estimate that she's going to get 12 yellows if she plays this game 50 times. Okay, that was the end of the Paper 2 AQA video. Hopefully you found that useful and helpful. If you did, don't forget to like the video, don't forget to subscribe to the channel, don't forget to leave me a comment to let me know if you find these videos useful and helpful, but otherwise, I'll see you for the next one.